In this video, we're going to be looking at the Exam 2 study guide for medication comes in liquid form with 200 milligrams of medication per milliliter. How many milliliters are required for a 450 milligram dose? Alright, so first, let's start with the 200 milligrams because that is the information that we know. So I'm going to put 200 milligrams on the bottom because I want to go to milliliters and I would like that to be on the top. Okay, and so now what the other value that I have is 450 milligrams, and they want to know how many milliliters are required. So to cancel out milligrams, I can multiply by the 450 milligrams. That will cancel these values. And I'll do top times top and bottom times bottom. So I've got 450 on top divided by 200, which gives me 2.25, and that's going to be in milliliters. A medication is dosed at 15 milligrams per kilogram of body weight. How many milligrams should a 225-pound person get? Okay, so let's start with the information that we have. We have a person who's 225 pounds, but for the medication, we need their body weight to be in kilograms. So let's get that to kilograms first. So for our from our conversion chart over here, we know that 2.2 pounds are equal to 1 kilogram. Pounds will cancel, and when I do that, I get 102.27 kilograms. Okay, and this information is going to be on a formula chart that is going to be available to you during the exam. So feel free to have it handy whenever you're working on these problems, just to kind of mimic the exam a little bit. Okay, so now that we have kilograms of body weight, we want to know how many milligrams they should get. So if this is the body weight in kilograms, we can multiply that by the number of milligrams per kilogram. And that's going to give us 1,534.09 milligrams. A medication is in liquid form with 200 milligrams of medication per milliliter. The medication needs to be infused at a rate of 10 milligrams per minute. What is the infusion rate in milliliters per hour? All right, so we're going to do a bit of a conversion here. So in this problem, I'm going to start with the 200 milligrams. However, our final answer is going to be in milliliters per hour. So I'm going to put the milliliters on top just so I can help myself out to get a nicer answer. So I'm going to put the 1 milliliter on top for every 200 milligrams. Okay, so now how can I get rid of milligrams? Well, I have the medication infusion rate, and it's going to be 10 milligrams per 1 minute. So that gets rid of milligrams. And now I want to go to hours. So from minutes, well, I know that there are 60 minutes in 1 hour. And that gets rid of my minutes. And then I can multiply all of these together. So I've got 1 times 10 times 60 gives me 600. And then on the bottom, I've got 200 times 1 is 200. Awesome. And then when we simplify and divide that, we get 3 milliliters per hour. So we keep this and we'd keep this, and those are our units. Alright, a medication is dosed at 8 milligrams per kilogram of body weight. The medication comes in a liquid form with 12 milligrams of medication per milliliter. What dose in milliliters should a 100 kilogram person get? Okay, so for this one, we're going to start with how much the person weighs. So let's start with 100 kilograms. And we want to know what dose. So our answer should be in milliliters. But first, let's get rid of the kilograms. So let's see. I've got a medication that's just at 8 milligrams per kilogram of body weight. So for every 1 kilogram, there's going to be 8 milligrams. Okay, so that gets rid of kilograms. And the medication comes with in a liquid form with 12 milligrams. So I'm going to put those on the bottom so we can cancel out units here per milliliter. So every 1 milliliter. And that's perfect because we want our answer to be in milliliters. All right, so this cancels out and we can multiply across the top. So I've got 100 times 8 times 1 gives me 800 milliliters. And on the bottom, 1 times 12 gives me 12. And when I do 800 divided by 12, that gives me 66.7 milliliters. Simplify 4x minus 8 plus 2 times 5 parentheses 5x plus 2 parentheses by combining like terms. Alright, so let's go ahead and write this out here just to give ourselves a little more room here. And something important to remember for simplifying is going to be our order of operations, or PEMDAS. If you don't remember what this stands for, it's going to be parentheses, exponents, multiplication, division, addition, subtraction. And this tells us in which order we should simplify. So for P, we start with the parentheses, and for this one, I'm going to start with the parentheses and I'm going to distribute the 2. When I do that and I multiply, I get 2 times 5x gives me 10x. 2 times 2 gives me 4. And the rest of the expression remains the same for now. Okay, now I want to combine like terms, like it says. So like terms are going to have x's with x's and regular numbers with other regular numbers, I guess you could say. And so I'm going to take 4x and 10x, and that's going to give me 14x. Then I've got negative 8 and 4. It's going to give me negative 4. And since this has an x, I can't combine it with the negative 4 because they're not like terms. So in this case, I'd be finished. All right, evaluate the expression for x equals 5. Okay, so what's going to happen here is every time that I see x, I'm going to substitute 5 instead. So let's start here. I've got 3, I see an x, I put a 5 instead. I'm always going to put parentheses around my 5 just so I can keep sign errors absent. Minus 2. It's okay that there's already a parentheses. I'm going to put another one. Times 5 plus 3. Okay. Now, I'm going to simplify, but just like in the other one, I'm still going to use PEMDAS every time. Order matters, okay? So start with parentheses. I'm going to do what's inside the parentheses first. 2 times 5 gives me 10. Plus 3. It's going to give me 13 inside the parentheses, and this is just going to drop down. Okay, now I can do the multiplication next, so it's going to be 15 minus 13. This gives me 2. Okay. Is 5 the solution set for this equation? Okay, so all they're asking is if we put 5 in for x every time we see x, is this equation going to be true? So let's find out. So let's do it on the left side. 2 times 5 minus 7. 2 times 5 gives me 10, minus 7 gives me 3. And then on the right, I've got 4 times 5 plus 12, 20 plus 12 gives me 32. Does that make sense? Does 3 equal 32? And the answer is no. So the answer for this would be no. Solve the equation for x. Okay, so I'm going to rewrite this just so we have a little bit of room to work with. And I'm also going to write something that's going to be very important, is our order of operations, or PEMDAS. Okay, now this is going to tell us the order in which we're going to solve this. So P stands for parentheses. So I'm going to start there and distribute this 4 to both the 2x and the negative 7. This is going to give me 8x minus 28. And then the left side's going to stay the same for now. And I'm going to combine like terms. So what that means is x's are going to go with x's, and regular numbers are going with regular numbers. So I'm going to subtract the 3x and move it over here. And I'm going to take the 28 and I'm going to put it over here. So add 28. We do the opposite of whatever is listed. Okay? So this will cancel and this will cancel. So I've got 8x minus 3x gives me 5x. And 5 plus 28 is going to give me 33. Now I'm going to divide both sides by 5 to get x by itself. So x is going to equal 6.6. And that is our answer. Alright, a medication has a half-life of 4 hours. If the initial dose is 220 milligrams, how much medication will be in the patient's system after 8 hours? Okay, so I've included the formulas for you guys down here. The formulas will be on your formula chart, so feel free to make use of them here. Get used to using them as you'll have access to them on your exam. So I'm going to write out the one that we're going to be using, and it's called the half-life formula. I'm going to write it up here. So the amount equals A times 1/2 T over T 1/2, which this is the half-life, this is the time, just 1/2, and then the amount, the initial amount. Okay. So let's fill in what we know. We've got the amount, that's what we don't know, equals the starting amount, which is going to be 220 milligrams, times 1/2, to the time, which is going to be 8 hours, divided by the half-life, which is 4. So when we simplify, we've got the amount equals 220 times 1/2 to the second power. Okay? And this can go in your Desmos calculator if you would like, but it's also really simple. If you distribute this exponent to the 1 and to the 2, you're going to get 220 times 1/4. Okay, and that's going to leave us with 55 milligrams. A patient takes 1,050 milligrams of medication. The nurse says that this is more than 3 times the normal dose. What is the normal dose of the medication? Alright, so we're going to write an equation. I'm going to come over here. So the patient takes 1,050 milligrams, And the nurse says that this is 250 more than 3 times the normal dose, which is what we don't know. So we're going to call that x. Alright, so we've created an equation. Now let's solve. Let's get x by itself by subtracting 250 from both sides. This comes down as just 3x equals 800 on the left side. Okay, now I can divide both sides by 3. It gives me x equals 800 divided by 3 is going to give me 266.7, and that's going to be in milligrams. Consider the expression, what are the coefficients and are there any like terms? Okay, coefficients. Coefficients is going to mean the number that is out in front of, in simple terms, all the letters, basically. So, when we look here, we're going to see that one coefficient is 4. One coefficient is -5. This gets included with the number. And then this one's going to be 7. Positive 7. So I've got, I'm going to write them out here, 4, -5, and 7. And then are there any like terms? So for something to be a like term, the letters behind the coefficient need to be exactly the same. So none of these here are exactly the same. Let's say if we wanted something the same as this, it would need to say 7 times a to the 5th times b. Like it would need to be the exact same. So we don't have any like terms here. Let's combine like terms. So first off, let's find the like terms since there's quite a few variables here. We want to, like I said in the previous problem, we want to look for variables that are exactly the same exponents, same everything. So I see one right here with this one over here, and the sign in front of the coefficient gets included. So I've got those two, and then I've also got one right here. I'm going to make this one a circle, and one right here. So now I'm just going to add or subtract the coefficients with this that are like terms. So I've got 4 minus 17, since those are the same, and that's going to give me -13. And all I do is just put the term on the end of it exactly as it appears, because it is the same. So a squared, b to the 3rd, and c. Okay? So now I've got the -5 plus the 8 for this one. That's going to give me a +3, a 5, and a b. And then I don't have a like term for this one, so I'm just going to copy it as it appears. So plus 7, A, B, C. We've got a true or false question. If two lines are perpendicular to the same line, then they are parallel. True or false? Well, if we've got two lines that are perpendicular, which means they intersect at a 90-degree angle, and they're both perpendicular to this same line, so I'm just going to draw another one, then they are parallel, meaning they have the same slope. Well, we see that this is true. Is there any way that this could not be true? Well, if this right here is going to be a 90-degree angle, and this right here is also going to be a 90-degree angle, these two have to be parallel. Okay? And a little tip, it's always helpful to draw a picture. Always helps me out to figure out what I'm looking at. Okay, find the complement and the supplement of an angle of 73 degrees. Okay, so let's start with the complement. And all a complement is we want to find an angle that we can add to the angle of 73 degrees that will make a right angle. So this is our 90. Okay, so we're going to do 90 minus the 73. That's going to give us an angle of 17 degrees. So the complement is going to be 17 degrees. Now let's do the supplement. And the supplement is a similar concept, except we are looking for an angle that's going to add to 73 to give us 180 degree, a straight angle. So we'll start with the 180 minus 73, and that's going to give me 107 degrees. Use the figure below of two parallel lines and a transversal. Find the measure of all of the angles. Okay. So I'll write our answers over here. 1, 2, there's 7 different angles that we need to take a look at here. Okay, and there's not a whole lot of math. There's a little bit, but when we have a picture like this, we have to know the rules. So 122 right here, we know that any angle that's set up like this, the one diagonal from it here, angle 3, they're going to be exactly the same. So that means that angle 3 is going to be 122 degrees. They're going to be exactly the same. So I'll write 122. Okay, now since we have a straight line here, we know, since we just did a complement, we know that this angle plus this angle has to equal 180. So to figure out angle 1, I can take 180 minus 122, and I'll get that angle 1 is 58. Degrees. Okay? Again, all I did there was 122 plus 58 gives me 180, and it has to be 180 because this is a straight line here. Now, like the rule we did before, same thing applies here. The angle diagonal must be the same. So that means that angle 2 is also going to be 58 degrees. Okay, and here we also know that these two lines are parallel. So we know that the angles are going to be the exact same. Okay, so angle 4 is going to be the same as the 122 that we have up there. Okay, now per the rule, angle 7 is going to be the exact same as angle 4 as well, 122 degrees. And then the same thing applies up here. Angle 5 and angle 6 are both going to be 58 degrees. So yeah, like I said, not a lot of math, just need to be aware of the rules that apply when we have two parallel lines and a transversal. Right? A rectangular wound is 10 centimeters long and 8 centimeters wide. What is the area of the wound? Okay, so if we got a rectangle, pictures always first. We've got 10 centimeters long and 8 centimeters wide. What is the area? So area of a rectangle, space times height. This is going to be on your formula chart, so no need to memorize it. You can just keep your formula chart handy. And the area is going to be 10 times 8, which gives me 80 centimeters squared. It's going to be my area. 17, flowers are to be planted at the edge of a circular flower bed with a radius of 6 feet. If flowers are to be planted every 8 inches, how many flowers are needed? Okay, so first they said that the flowers are going to be planted around the edge. This keyword right here tells me that we need to find circumference. Okay? So, to find the circumference, we know from your formula chart, you can take a look now if you like, circumference equals diameter times pi. But they didn't give us diameter. What did they give us? They gave us radius. Well, I know that radius times 2 is going to give me the diameter. So I've got a radius times 2. That means my diameter is going to be 12. So let's find circumference first, then we can work on the flowers that are going to be planted every 8 inches. So I've got C equals 12 times pi. And in your calculator, you can type that in as 12 times 3.14 or use the pi button. And I'm going to get my circumference to be 37.68 feet. Okay? Now, we know that flowers are planted every 8 inches. However, my circumference measurement here is in feet. So let's convert 8 inches to feet as well. So I've got 8 inches out of a whole foot would be 12 inches. And this I would get 0.67 feet. Okay? So if they're to be planted every 8 inches, I need to divide the both of these. So the total length around the edge of the flower bed in feet divided by the distance between each of the flowers. And when I divide this, I get 56.5197. Now, we do get quite a lengthy decimal here, but since our answer units is going to be number of flowers, we can round because we want a whole flower. So this is going to be 57 flowers. Okay, what is the area of the carpet needed to cover a circular area with a radius of 5 feet? So we're doing circular area. And the formula for that, which is also on your formula chart, is going to be A equals pi r squared. All right? So I've got A equals pi, and then my r is 5, so that's going to be 5 squared, which is really just 25 times pi. And when I multiply that out, it's going to be 78.5 feet squared. Area is always going to be units squared. If we're working with circumference or diameter or radius, those are going to be regular units, but area is going to be units squared. Okay, and an isosceles triangle has one angle of 110 degrees. What are the measures of the other two angles? Well, we know that in an isosceles triangle, two of the sides, so here we go, I'm going to draw a triangle for you here. Two of the sides are going to be exactly the same. So if those are exactly the same, and this angle right here, what they told us is 110, we know that these two angles over here also have to be the same. So what is one other thing that we know about all the angles in a triangle? Well, eventually, no matter what kind of triangle, they're all going to add up to 180. Okay? So 180, all the angles are going to equal 180. I know that one angle is 110, and the other angles have to be the same, so I'm just going to write them as x. There's two of them, and they're both going to be the same. So now we can solve the equation here. To get x by itself, I'm going to subtract 110 from both sides. When I do that, this will cancel out, and I'm left with 2x equals 70. I can divide by 2 on both sides. This cancels, and I'm left with x equals 35 degrees. So both of the angles are going to be 35 degrees. A right triangle has one angle of 35 degrees. What are the measures of the other angle? All right, so right triangle, by definition, means that one of the angles in the triangle must be 90 degrees. We indicate that by a little square here. And it says that the other angle, there's one other that's 35 degrees. Okay, and so we want to find this one here. Well, per the last question that we looked at, we know that all the angles in a triangle must add up to 180. So I know that one of them is 90, the other is 35, and I want to find the last one. Oops. Plus x. Okay. 90 plus 35 gives me 125 plus x equals 180. When I subtract 125 from both sides, I get x equals 55 degrees. It says a right triangle has leg lengths of 5 and 7. What is the length of the hypotenuse? Okay, so a right triangle, let me turn my pen on here. A right triangle has two leg lengths of 5 and 7. Now the hypotenuse, by definition, is going to be the longest side of a triangle, so this is going to be the one we're going to find. And since we know that this is a right triangle, we know that we can use the Pythagorean theorem. Now, I'm going to write this formula out here for you, but this is going to be on your formula chart as well, so no need to commit it to memory. Okay, so we're going to take, this is side A and this is side B, and we're going to put these numbers into our formula. So we get 5 squared plus 7 squared equals c squared. Alright, so now we've got 5 squared, which is 25, plus 7 squared, which gives me 49, equals c squared. And then I get 25 plus 49 gives me 74 equals c squared. So now I'm going to take the square root of both sides to isolate c by itself, and when I do that, I get a rounded answer of 8.6. Okay, nice job. A right triangle has one leg length of 5 and a hypotenuse length of 7. What is the length of the other leg? So I've got a right triangle here, and one length is 5, and the hypotenuse, which is the longest one, is going to be 7. That's always going to be the side that is across from the 90-degree angle. And we want to know what b is. So let's use our formula again. A squared plus b squared equals c squared, which is going to be 5 squared plus b squared equals 7 squared. We can simplify this out to 25 plus b squared equals 49. I'm going to subtract 25 from both sides to get b by itself. And when I do that, this will cancel, and I'm going to be left with b squared equals 24. And my last step is to take the square root of both sides to get b by itself. And I'm left with b equals 4.9. 3. Find the measures of all the angles in the image below. Drawing is not to scale. Okay, so looks like we have 5 angles here. So I'm going to make our answer list over here. 4, 5. Alright, so I love these problems because they're kind of like a puzzle. So let's think about a triangle. What do we know about a triangle? And specifically the angles in a triangle. Well, I know that no matter what, all 3 of these angles must add to 180. So here I know that this one is 42, and I know that this one is 90, so we should be able to calculate what angle 1 is. So we can do 180 minus 42 minus 90. And if you type that in your calculator, you can get 48 degrees. Okay. Awesome. So if I know that this one is 48 degrees, I also know that anytime I have two intersecting lines like this and the angles across from each other are going to be the exact same. So what does that tell me about angle 3? Well, I know that it's 48 degrees as well. Okay, so I know that this one is 48 degrees. Now, we can do the same thing with this triangle because we know that all of these have to add up to 180. So I can do, to get angle 5, I can do 180 minus 92 minus 48. And that's going to give me 40 degrees, which is angle 5. Okay? All right, so I've got 2 and 4 left. Well, what do I know about 2 and 4? I do know that this right here is a straight line, which tells me that angle 1 and angle 2 must add up to 180 because this line is straight. So if I know angle 1, I can take 180 minus angle 1, and that will give me angle 2, which is 132. Okay? And then if I know this, angle 2, I also know angle 4, because just like the opposite angles here were the same, the opposite angles here are the same as well. So angle 4 is also going to be 132 degrees. A study is being conducted on stress levels during exams. The professor conducting the study uses 50 of their students as test subjects and measures stress factors during the exam. Which is the best answer? Okay, so they want to know whether or not this test that was being conducted was random or not. Let's look at choice A. Random. It was random because all the students are the same regardless of the school. Well, that can't be true because they're not all the same. This one says not random because there may be differences in how tests are administered at different schools. While this is true, we still don't know, even if they were different, the students still aren't the same. So that can't be true. Not random, but could be made a random sample by sampling 10 students from a random selection of 5 random schools. Yes, because we want to see a sample of a random selection of schools. You could actually make a random sample, yes. So we're going to go with C. It says create a stem and leaf plot for the data. Okay, so the most helpful thing to do when creating a stem and leaf plot is to first order your data from smallest to greatest. So let's start doing that here. We've got 13, 15, 17, and again, this is not necessary, it's just helpful. So 25, 26, 29, 32, 30, and then 2 32s. 38, 41, and 57. Okay, so for a stem and leaf plot, all you're doing is you're taking the first digit of all of the numbers. So I've got numbers with the first digit of a 1. I've got numbers with the first digit of a 2. I've got numbers with the first digit of a 3, 4, and 5. 4, and 5. Okay. It's a little tight down here, but that's okay. All right, so then we want to include the numbers, the second digit in each of these numbers since they're all two-digit numbers. So the first one is I'm going to draw a line. And then this is going to represent, the 3 is going to represent the 13. The 5 is going to represent the 17. And the 7 will represent the 17. Same thing here. Draw a line. 5, 5, 6, 9. Okay. I'm going to do the rest of it up here, but it would just keep going. So I've got 3, line, then a 0, 2, write it twice, 2, and an 8. For the 4, I would just write a 1. And for the 5, I would just write a 7. This allows us to see our data in a more concise way of looking at it. Use the frequency diagram below to answer the questions. First part A, what is the sample size? So we would get the sample size by adding all of the frequencies together. So let's do that. I've got 8 plus 12 plus 14 plus 10 plus 6 gives me 50. So my sample size is 50. How many are in the 10 to 14 range? So I go to age, go down to 10 to 14, and the frequency is going to be 14. Okay? How many are 14 or less? So they can be 14 or less than 14. So in which case I would add this frequency, and this frequency here, since these are all less than 14. So I've got 14 plus 12 plus 8 gives me 34. A group of 8 children produces the following heights. Find the median height. Okay, so for the median, we need to first put all of our data in order from least to greatest. So let's give ourselves a little more room here. Okay, from least to greatest. So let's start with 131, then 135, then we can go 137 and 138. Then I can go 2 140s, and then 141 and 142. Okay, so finding the median. First thing we do is we take 1 off of each end until we get to the middle. And that is what median means. It means middle. And if we have 2 left, we take the average of the 2. So to do so, we can add 138 plus 140 divided by 2. 138 plus 140 gives me 278 divided by 2 gives me 139. Okay, that is our median. Okay, find the mean. So to find the mean, we're going to use Desmos over here. So to find the mean, we're going to add all of the values together and divide by the number of values, which is 8. So we're going to use Desmos to help us out. Just a little bit. Let me make a little bit of room for us. Okay, so let's add all of our values together. We've got 138 plus 135, 42, 141, 140, 137, 140 plus 131. Okay, that is the sum of all of our values. So we need to take that number and divide by the number of values, which is 8. So let's do 1004 divided by 8 gives me 138. So our mean is going to be 138. Okay. C, find the standard deviation for the height. Okay, so cool thing about Desmos, it actually has a function for standard deviation because calculating standard deviation by hand is quite the lengthy process. So if you want to find it, you can go to function. Normally it would be under main, but you go to function and then you click standard deviation. And then you're going to type all your values in separated by a comma. Okay, so let's go for it. We can go 138, comma, just type them in as they appear. And you'll have access to this calculator on your exam as well, so feel free to use it as much as you like. In close parentheses, and we see that our standard deviation is 3.6253. Okay, awesome. All right, true or false? The mid-range is the overall spread of the data divided by 2. So if we look over here, this is going to be a part of your formula chart. You will have access to this as well. And we look at the mid-range formula and we see that this is false because the mid-range is the lowest value added to the highest value divided by 2. It is not the overall spread. All right, true or false? The range is the difference between the largest and the smallest value. So we look at range, we see highest minus lowest, and yes, this is true. All right, we've got 2 statements here. True or false? The mean can be affected by outliers, making it sometimes misleading. Absolutely, yes. Because in the mean, according to your formula chart, you're adding all of the values together and dividing by the number of values. So if one value, let's say, is super large, that's going to affect your sum total of all the values quite a bit. So yes, this is true. The second one says the median can be affected by outliers, making it sometimes misleading. And this would be false because the median, if you'll remember earlier when we found it, we took 1 off of each end. It's not really going to be affected by outliers. So this would be false. Okay, that concludes the Exams 2 study guide. Study well. I hope you guys found this helpful, and I hope the exam goes well for you. See you next time.